magnetic field of a bar magnet presentation. The purpose of this lab is to measure the distance dependence of the magnetic field due to a small bar magnet, and to compare the measurement to distance dependence predicted by the equations for both on-axis and off-axis magnetic fields derived from the biosavariant law, and to simulate it. And the results I got from the lab are the magnetic dipole is 3.49 am squared, and the n value is negative 3.07. The principles I used throughout the labs are the two biosavariant law equations, the linearization equation, and the distance dependence equation. One assumption I made throughout the lab is the only other magnetic interference is Earth, and two possible sources of errors are potential inaccurate measurements and any other possible magnetic field interference. Regarding the setup of this experiment, the system is the magnetometer and the surroundings is the bar magnet. Two initial conditions of the lab: the magnetometer, our phone, is facing north, and the bar magnet aligned perpendicular to phone. Here are the procedures of the lab. For on-axis, I measure the distance between magnet and sensor Bx value 20 mu Tesla. I repeated the steps for the other four sensor Bx values. And for off-axis, I first zero out the y-pin component, then found the d-perp, which is the distance where the magnitude is 100 mu Tesla. I positioned the sensor at d-perp and recorded it. Finally, I calculate and determine the vector magnitude field at the location. The three observations I made throughout the labs are: when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, and the smaller distance creates a larger magnetic field. And regarding the results of this experiment, for on-axis, I calculated the magnetic dipole moment to be 3.49 am squared. Using the linearization and distance dependence formula, I calculated the n value to be negative 3.07 and the k value to be 6.97 times 10 to the negative 7. And for off-axis, the average distance is 0.271 and the average B net value is 1.9095 times 10 to the negative 5 Tesla. And regarding the coding of this lab, I first replaced the empty vector and zero values with my values that I calculated, and then using the biosavariant law, I was able to create a function called dipole B to help calculate the magnetic field. Then from there, I created lines of code to visualize the magnetic field produced by the bar magnet, both along the axis and perpendicular to the axis, and also along a line tilted 45 degrees to the axis of the magnet. And finally, to answer the two what-if questions, the answer to the first question is the final answer would have been affected and not correct, and the answer to the second question is the physical principle concept would still be successfully demonstrated. However, the magnetic field would be greater than before due to the idea of superposition. Thank you.